Welcome back. This lesson follows the 7 controlled experiments in wells 1 through 7. We were looking to see which of these fizzers was most like the mystery mixture. So which combination had the same fizz time, same fizz look, etc. I asked you to, throw in a mystery mixture experiment every once in a while, just so that you could have a fresh look at what it is that you're looking for. So the mystery mixture was fizzing. Which of these combinations was most plausible? You should have narrowed down the possibilities to 3 now. There were 3 combinations that fizzed just like the mystery mixture. They were in well number 6, citric acid and sodium bicarbonate. In well number 7, citric acid and sodium carbonate. And again, well number 8 was the mystery mixture, the thing we are comparing it to. And there was one more, ascorbic acid and sodium bicarbonate, all of which looked and acted the same as the mystery mixture. Here's what they had in common. The mystery mixture had the same time elapse. So as far as the mystery mixture, they were both the same amount of time. There was also a clear liquid at the end, just like the mystery mixture, with no residue left on the bottom. So now I have narrowed it down to 3, well number 2, 6, and 7. And I need to go a step further in my experimentation to determine which one of these combinations is the mystery mixture. You might recall from my previous video that in a chemical reaction, I start with reactants on this side and I end with products on this side, and it is a one-way direction. A chemical reaction cannot be reversed. So in this case, we start with 2 of our white substances, plus we added water, and it yielded, remember the word is yielded, a gas. Kind of reminds us of the gas in pop. Does anyone know what that gas is that fizzes when you drink a soda? But then there was also something else in each of those wells. The gas was released into the air. We show that by an up arrow. The gas was released into the air. But there's some residue left in the bottom of each well. In order for me to see this residue, what will I have to do? What will have to go away for me to see what is left in the well? So we're looking for what is over here. 1, we know it was a gas plus something else. The only way to see what is left over is to let that water that is extra evaporate. So these are the evaporation results times. Now, if you're in class, I would have asked you to not rinse out your wells after the 7 experimentation, and I would ask you to let it sit overnight so that the water could evaporate. And that way we can see what is left in the wells and compare it to the mystery mixture number 8. Again, we're looking for what is left so that I can take my 3 and narrow it down to just 1. At this time, I want you to pause your video to observe the evaporation results in class, the actual wells where the water has evaporated. So again, we're looking at the evaporation results, and we're comparing well number 8 to the 3 reactions that we think it might be. So again, we're comparing number 8 to those 3. Once you look at the residues in the wells, I want you to write on your mystery mixture summary B sheet at the bottom, write which one you believe is closest to, or 2 that are closest to your mystery mixture. I'll give you a hint. There are probably 2 evaporation wells that look exactly like well number 8. Which 2 are those? Please go into your Notability, filing cabinet, find the mystery mixture summary B, and at the bottom, fill out which mixture or mixtures you believe it could be. One handy tool to use is in your FOSS web application, so www.fossweb.com. Don't forget to put your school email and password to log in. But under multimedia for chemical reactions, under multimedia, there is a video called Two Substance Reactions. So again, this is under multimedia. And if you click on that, you'll get to do virtual experimentations of the 7 experiments. But really, we're just looking for the three possibilities. So I would like you to use this tool whether you're in school or not, because at the top of the tool, after you experiment, you can click on evaporated product, so you can see what is left after the gas and the water are both gone, the water's evaporated, to compare. And what you will have noticed after using this research, and I want you to check for yourself, is that there is now only 2 possibilities. Only 2 possibilities. They are the citric acid plus sodium bicarbonate, or baking soda, or the other possibility is citric acid plus sodium carbonate. Those are the only 2 that dried clear, just like the mystery mixture. The the ascorbic acid well in well number 2 dried red. You can prove it by looking at this little simulation under multimedia. And our mystery mixture definitely did not dry red. Our mystery mixture dried clear, just like these 2 combinations. So we've gone from many, many, many combinations of white substances to 7. Then we whittled it down to 3 that fizzed the same as the mystery mixture as far as duration and color. But then we let the water evaporate, leaving only now 2 possibilities, which are citric acid plus sodium bicarbonate and citric acid plus sodium carbonate. We must conduct one more experimentation to find out what is the mystery mixture. All right, so down to 2 possibilities. Is it citric acid plus sodium bicarbonate? Or is it citric acid plus sodium carbonate? There's only one thing left to do: conduct large-scale reactions. If you're in class, you're going to obtain not the mini wells, but big cups where you can mix these 2 at a time. And this will allow your hands to wrap around and feel the outside of the plastic as they are either warming up or cooling down. Now, I realize that if you are learning remotely today, you cannot conduct these large-scale reactions. However, in the next video, we'll explain what we felt. But one thing that we had never considered before is that a chemical reaction might cause a temperature change. And if I use a large clear plastic cup, my hand should be able to feel through the cup. So let's go ahead and conduct citric acid plus sodium bicarbonate in one, and citric acid and sodium carbonate in another, to figure out which one is the mystery mixture. At the conclusion of these large-scale reactions, make your final decision on your mystery mixture summary page and submit that page with all of your notes and observations into Canvas, please. Those of you learning remotely, if you have not been able to feel the large scale reactions, make your best educated guess and find out in the next lesson which one it is.